last lesson we learned about the graphs for inequalities, and today we're going to start learning about how to solve them. To solve an inequality, we want to get the positive variable by itself, meaning with no coefficient on one side. It can be on the left side or the right side. And, whatever side the variable's on, the solution is on the other side. To get the variable by itself, we will have to do the opposite or the inverse operation that is happening to the variable. So if something is being added to the variable, we want to do the opposite and do subtraction. If subtraction is happening to the variable, we want to do the opposite and do addition. If multiplication is happening to the variable, we want to do the opposite and use division. And if division is happening, we want to do the opposite, which is multiplication. So I'll make sure you've got those, so I'll leave that there a moment. Now you may think, this seems really familiar. Didn't we already do these notes? Sort of. It turns out that the steps to solving an inequality are pretty much the same as solving an equation. And let's prove that. Now I'm going to have you check your answers on these notes. I don't know that I'll have you check them very often on homework or on quizzes and tests, but for reasons you'll understand, there's a reason there's a ... right there. You'll see why I'm going to have you check it on these notes. So these are just one-step inequalities. So like one-step equations, they're pretty quick. Right now, 5 is being added to x. So if we want to solve for x, we have to do the opposite and subtract 5 from both sides. 5 minus 5 is 0, leaving just the x by itself. 12 minus 5 is 7. So that's our solution. Now to check it, there's a difference between checking with equations and checking with inequalities. This does not say x equals 7. This says x is greater than 7. So to test this, I want to pick any number that's bigger than 7. You could pick 8, you could pick 10, you could pick 1,000. Any number that's bigger than 7 will work. I'll just pick 8 to be simple. So I pick a number bigger than 7, go back here to x, plug in 8. 8 plus 5 is 13, and 13 is greater than 12, so our answer checks out. So our solution is that x is greater than 7. On number 2, 11 is being subtracted from y, so we wanted the opposite of subtraction and do addition, so we'll add 11 to both sides. So we have 19 is less than or equal to y. And I told you on graphing, you want to make sure that the variable is always on the left. So you can rewrite this direction. You just put the y first, flip the inequality sign, and write the 19. Because saying 19 is smaller than y is the same thing as saying y is bigger than 19. But as far as just solving, this answer is just as good as this answer. So you don't have to flip it around unless you want to when you're just told to solve. It's just when you're graphing that I highly recommend you flip it around this direction. Oh, and let's check our answer. So y, it does make it easier to check this way too. Y is greater than or equal to 19. Now since it says we're equal to, we could choose 19. So I'll do that this time. We couldn't do it here because that doesn't say or equal to 7. We can use the actual number here because it says or equal to 19. So I plugged in 19 for y. 19 minus 11 is 8, and 8 is equal to 8. Because remember, we talked about this. It doesn't have to be less than, just has to either be less than or equal to. Since 8 is equal to 8, it means we're good to go. Okay, on number 3, x is being multiplied by 6. So I want to do the opposite and divide by 6. So I get 4 is less than x, which I'd certainly accept that as a correct answer. But you could also write it as x is greater than 4. So both of these are legitimate answers. And if I want to test it, it says I have to pick a number bigger than 4. So I'll just pick 5. So 24 is less than 6 times 5. 24 is less than 30. That's true. Since 24 is less than 30, our answer checks out. Okay, last example. B is being divided by -3. Remember, that's what a fraction is. A fraction is division. So the opposite of dividing by 3 is multiplying both sides by -3. Let me say that again. They're dividing by -3, so we'll multiply both sides by -3. Because -3 divided by -3 is 1, so that cancels out, leaving just b. -15 times -3 is +15. So this says this should work if b is any number bigger than 15. So I'll just pick 18. I just chose 18 because I know I can divide that by 3 and it come out to a whole number. So 18 divided by -3 is greater than or equal to -5. 18 divided by -3 is -6. Uh-oh, wait a minute. -6 is not bigger than -5. It's obviously not equal to it, so something's wrong here. Well, that's why I wrote this the way I did. In short, the steps to solve an inequality are the same as solving an equation, with one exception. With inequalities, when you divide or multiply both sides by a negative number, you must flip or reverse the inequality sign. So back to this question. It's not that we did anything wrong in multiplying by -3. That was the right move. But because we were multiplying both sides by a negative number, it's not because the 5 is negative. That has nothing to do with it. Because what we're multiplying both sides by is negative, we have to flip the inequality sign the other direction. So let's test this one out just to show it does work. This says we can pick any number smaller than 15. Well, an easy number to use is 0, and 0 is less than 15. So I'm going to plug 0 in for b. 0 divided by -3 is 0. And 0 is bigger than -5, so that checks out. So our correct answer is less than or equal to 15. So please remember, whenever you divide or multiply by a negative number, you have to flip the inequality sign. You never have to flip it when you're solving by adding or subtracting. And you don't have to do it when you're dividing or multiplying. You only have to do it when what you're dividing or multiplying by is a negative number. That's why I didn't flip the inequality from here to here. But I have to from here to here because I was multiplying by a negative number. So put this in your memory. When you divide or multiply both sides by a negative number, you must flip the inequality sign.